Now let's take a look at how we can find the area of a sector. So remember, a sector is this slice of pizza out of this full circle, if you will. Now it has area because it takes up space. An arc itself doesn't really have any area because it's infinitely thin. It's just made up of a bunch of points, but not arranged in a straight line, arranged more in kind of a portion of a circle type shape. But a sector itself takes up space, so we can find its area. And we're going to use a similar idea to what we used when finding arc length. Whereas the length of an arc was kind of a fraction of the full circle's circumference, the area of a sector is a fraction of the full circle's area. So if I could kind of apply that idea as a proportion, I could say that the area of a sector over the area of the circle, that ratio should equal the measure of the arc over 360. And so that would let me say that the area of the sector over pi r squared, because pi r squared is how we find the area of any circle. We take pi times the radius squared. So that fraction should equal the n, which is we're going to call the arc measure, over 360. So here's like a proportion that would be useful for us if we're trying to find the area of some sector. And then if we rearrange this proportion to isolate the A part, the area of the sector part, it's going to give us this, which actually looks pretty similar to the formula we used to find arc length, right? The formula we used to find arc length had n over 360 times the circumference formula. Now we just have n over 360 times the area formula for a circle. So let's see how we can put this one to use. This example asks us to find the area of this sector. So we notice that the central angle for this sector has a measure of 165, which would tell us that this arc also has a measure of 165, and the radius of this circle is 3. So my formula says to take the arc measure over 360 and multiply it times pi r squared. So in this case, I'm going to take 165 over 360 and multiply that times pi times 3 squared. Or I can think of that as 165 over 360 times 9 pi. I just simplified pi times 3 squared and made it 9 pi. So now this is the point where I grab my calculator and I type in 165 over 360 and then multiply that times 9 pi. And I'm going to get an answer that says the area is about, see, it says 12.959, so that's going to round, if I do the nearest tenth, that's going to round to about 13.0. Now here's another term you're going to need to know. It's called a segment of a circle. And to create a segment of a circle, what we do is we take an arc. All right, we got this arc here. Let's say that this arc has n points at A and B. So we'll say this is point A and this is point B. So we have this arc AB, and then we connect A to B with a segment. So A and B are connected twice. They're connected with an arc, and then they're connected with a segment. And that space that we enclosed there, the space here that's shaded this orange color, is what we call a segment of a circle. It's bounded by an arc and the segment joining that arc's endpoints. And we can find the area of that actually fairly easily. If we want to find a segment area, we're going to imagine first that we find this sector area, right? We find this entire sector's area using the formula for sector area, and then we're going to subtract the area of this triangle that's a part of this sector, but's not a part of this segment. All right, so that sounds a little bit confusing, but it's just that we're going to take this bigger shape's area, which is a sector, and we're going to just take out this triangle right here that's not included in the segment portion. And so the sector area formula, we learned that just a few minutes ago. We're going to take our n over 360 and multiply that by pi r squared, and then we're going to subtract the triangle area. Well, how are we going to find the triangle area? Well, theoretically, if we're finding the sector area, we know the measure of this arc. But that would also mean we know the measure of this angle, right? That n degrees is the arc measure, but it's also the angle measure. And of course, this angle here has sides that are 1 radius long, whatever the radius is of our circle. So a little while back, we learned a formula for finding the area of a triangle that says we can take 1/2 of 2 sides multiplied together times the sine of the angle that's between those 2 sides, right? This was a kind of a new area formula we learned for finding the area of a triangle. Take 1/2 of 2 sides of the triangle multiplied together times the sine of the angle that's between those 2 sides. Well, look what we would have. We would have this angle measure. If we're able to find their sector area, we're going to have this angle measure, and we're going to have these 2 sides of this triangle. So we're going to take, for the triangle area, we're just going to use this formula, only we're going to replace the A and the B with R's. So this will be 1/2 of radius times radius, right? It'll be 1/2 of radius times radius times the sine of n. So using the same variables that I used over here, n and r, I can write this formula. It'll say 1/2 of r squared times the sine of our n, sine of n. And this is how we can find a segment area. N over 360 times pi r squared, that's just finding the sector, and then we're going to subtract 1/2 r squared times sine n, which is the triangle area. So let's try that right now. We're going to find the area of that segment that's shown on this picture, and we're going to find that by taking n over 360 times pi r squared, right? That's going to be my sector area, and we're going to subtract 1/2 r squared sine n. So all I need to do now is I need to take my n value, which is 144 degrees, the arc measure, and my radius length, and plug them in here and here for n, here and here for r. So I'm going to rewrite this to say 144 over 360 times pi times 5 squared minus 1/2 times 5 squared times the sine of 144. Now I'll clean this up a little bit. I'm going to go ahead and do 2 separate calculations on my calculator. First, I'm going to do this. I'm going to take 144 over 360 times 25 pi, right? Because I know that this pi times 5 squared will be 25 pi. So 144 over 360 times 25 pi gives me about 31.4. And then I'm going to take my calculator and do the 1/2 times 5 squared times sine 44. So I'm going to take 0.5 for 1/2 times 25 for the 5 squared times sine 144. And that's going to give me about 7.3. And then I'm going to subtract those two. So 31.4 minus 7.3 is going to give me a value of about 24.1.